So in our last video, we proved that work and energy are essentially the same thing. So with that, let's go ahead and redefine work. And work, one way to look at it is the amount of energy given to or taken away from a system. And if you think that's a very broad, not at all specific definition, I did that on purpose. Because I want you to understand that this is true for any system where work is done or where energy is used. So if I'm taking a rock up from the ground, if I'm picking up a rock, that is work, and the work is the amount of energy given to or taken away from that rock. Or if I throw a baseball, the work I'm doing is the amount of energy I'm putting into that baseball. And so to measure energy, let's try to keep it somewhat grammatically correct here, but to measure energy, you need to measure the work done for the system to acquire that energy. So for the system to acquire, spell that right, that energy. And so one of the main things I want to drive home in this video is that this is true, these statements are true for all types of energy. And so again, this is why I'm keeping these statements so broad when I say the word system. Because no matter what type of energy you're using, so we talked about some types of energy. So we talked about potential energy, for example. We talked about kinetic energy or moving energy. These statements are true for both of them. In the last video, we also talked about thermal energy. This is also true for thermal energy, which is another way of saying heat, actually, in case you were wondering. But this is true for solar energy, which is actually just radiant energy, is the way they say it in science. But you can think of it as interchangeable with the word solar. But these statements are also true with mechanical energy. I'm going to stop writing energy, I think. But this is also true for electrical energy. This is true for nuclear energy. I can't stress this enough, that this is true for all other types of energy. How you measure them is by measuring the work done or whatever system it is to acquire that energy. That's kind of my point here. And so with that in mind, let's go ahead and let's talk about some of the things. So first off, or at least not talk about other things, but I should say explain some details. But first off, let's point out something that we all know, hopefully by now, is that energy cannot be created or destroyed. And hopefully you've learned that by now. It's been beating your head over and over again. But here's the thing. It can be converted or transformed into other types of energy. So hopefully that statement wasn't too mind-blowing, but something you need to understand is when it is converted, so let's try to be somewhat grammatically correct here, but when it is converted, some energy is always lost to other forms of energy. And that is, of course, usually heat, but it could be other things like sound. And actually, let's not just write the word heat. Let's say usually heat. And actually, you should have a tape in that you taped in somewhere in your notes already that looks something, sorry about that noise, it looks something like this, where it actually talks about converting energy. And they're talking about the several different ways to convert different types of energy, like fossil or solar or wind, all into electrical energy and how that's done. And if you tape that incorrectly, hopefully you're around at that area right now. This should match up with your notes if you were taking your notes correctly and you taped that incorrectly. So hopefully those lined up pretty well for you. But let's go ahead and let's talk about some examples. of energy transformation or energy conversion. Transformation or conversion. So for example, where do we get the energy to run? Where does that come from? Well, if you think about it, that's pretty simple. We get it from our food. We get our energy from our food, but somehow that is turning, or we're turning our food into kinetic energy, so into the ability to run, let's say. And what is that? Well, food is just chemical energy stored. And running, I should say, I keep giving away the answer. Running is kinetic energy. It's just a form of moving energy. So that's pretty simple. That's how we do it. But what about energy for plant growth? Where does a plant get its energy from to actually grow? So let me go ahead and tab this out just a little bit. Well, hopefully you know by now that a plant gets energy from the sun, but somehow it's converting that sun into growing. And this should say energy for plant growth. I'm so sorry that it doesn't. Let's go ahead and add that real quick, and let's tab this out a little bit further so they line up to soothe my OCD. But what is that? Well, we said earlier that solar energy, or the sun, is just radiant energy. And what the plant is doing is it's converting that radiant energy into essentially its chemical bonds that make up what the plant is. So it's converting it into chemical energy, essentially. Let's do a simpler one now. Let's do something super simple, hopefully not hard at all to figure out or to work out. Where does the energy, sorry for that sound, where does the energy to heat a house come from? How does that work? How do we convert that energy? And the answer, hopefully, is just incredibly obvious. We are turning the electrical energy supplied to our house directly into heat. And so these are all examples of converting energy. And an important thing to remember, important thing to understand, is that every single time we do convert energy, we are losing some of it. And we'll talk about that idea more in detail in the next video.